we are running models that have take it through kind of the first decade and the second decade, and we're not really seeing degradation of the panel itself.
Welcome to the Passive House podcast, brought to you by Passive House Accelerator, a catalyst for zero carbon building. For news, inspiration and connections from all flavours of Passive House, check out passivehouseaccelerator.com. Sign up to receive regular updates about events, get your questions answered and contribute to the community dialogue. There's loads of free information for experienced professionals and people just starting out on their Passive House journey. We hope to see you at one of our weekly Passive House Accelerator live webinars. You can also check out our Reimagined Buildings YouTube channel for some great inspiration for both building new or renovating. In the meantime, here's this week's Passive House podcast. Welcome back to another episode of the Passive House podcast. And with us this week, again, we have Mary and Ilka. Mary, how are you?
I'm good. Yeah, happy to be on the West Coast.
Happy to be on the West Coast, yes. And as well as Zach, you're relatively safe there.
Yeah, breathing easy. Mm-hmm.
Yeah, breathing easy in Seattle. Ilka, over in Philadelphia on the East Coast, how's it going?
Well, a little bit better today. Yesterday was pretty tough since we're not really used to breathing in smoke from wildfires in Canada. So yeah, it's a little harder to breathe here. Vision is not very good. I'm sure you've seen some images from New York with all orange skies. And yeah, it's definitely something new for us. First time that I really checked and know more about air quality index than I've ever known before.
Yeah, I imagine a lot of people. So we're recording this as Thursday, 8th of June for you. You all, so a couple of days into, well, when did the wildfires start? Earlier this week?
I think it started for you in like Tuesday, probably getting bad, right, Ilka? And then yet Wednesday was particularly bad. Yeah,
we started feeling it on Tuesday, and really bad was last night, where they canceled baseball games and schools didn't have any outdoor activities. And the index for us went up to 450, which was in the maroon area, which I've never, ever seen before. Yeah, right now we're still in the 170s, which is still an unhealthy category, but it feels like a relief compared to last night.
Yeah. Mm-hmm. And as you're saying, so this is pretty new, something new for the East Coast. Zach, you're sort of getting, and Mary getting a little bit, unfortunately, too familiar with these sorts of events, having wildfires in the summertime that are not necessarily right where you are, but you getting the effects of them. But Ilka, is that? Mm-hmm. I mean, is your building like your daily life? Mm-hmm. Are you able to be in a place that has clean air, or is it just everywhere?
Well, I wish I was in a passive house, but unfortunately I'm not. My office at least has a little mini split in the room, so at least I can circulate the air and filter it that way. But right. It's not really a relief. I mean, sure, it's a relief to go inside and we close the windows better than outside, but it's not that I have filtered nice air around me. So my eyes are still burning, basically.
And I imagine that must be the case for most people. I mean, most people would only be relying on the news to tell them what the index is. That most people don't have air quality sensors like some of us might.
Yeah, or the weather app.
Right. But then, what can you do if you're not one of those people that has a good filtration system? And I imagine a lot of school buildings, a lot of office buildings aren't necessarily that great.
No, definitely not.
There's a strategy called, or a device called a Corsi-Rosenthal box, which is essentially you take a box fan and take what would it be 5 furnace filters and turn it into a cube. So the box fan is one of the 6 faces. Well, no, you would use 4 box fan filters and then one piece is just on, that's the base of this, right? Yeah. So imagine this cube, and you use that to have a really large surface area of filtration and then you run that fan 24/7 inside as a makeshift way to clean the air inside buildings.
You just scrub your own internal air.
Yeah, exactly. And that's what is necessary. You just have to do that, because it's really our normal leaky buildings are just they become totally unsafe. Even inside. So there needs to be, or you can also run an HVAC, like if you have a central furnace, just run the air at least all the time with a high MERV filter, so that you can be filtrating some of the contaminants out that way. Of course, you can spend a few $100s on a fancier air filtration device as well. But like there's now this kind of community of people who are sharing this information about how to do these DIY boxes for those of us who are in these wildfire zones as a kind of makeshift solution. But what that does not do is help you with the rising CO2 levels inside during these events. And so, ultimately we need to have filtered air that becomes fresh because it's filtered from outside. So I'm curious, Mary, to hear what your experience is in your passive house, and have you put on some of that extra filtration to your HRV or ERV? I don't remember if you have an HRV or ERV to help with that.
Yeah, I have an HRV, and we put on extra filtration, just like a pre-filter for the incoming air. And fortunately, since we set it up, we haven't had a smoke event. So, but now we're ready for the next smoke event, which I know is inevitable because it's happening pretty much every summer. Although we got away with no smoke event last summer. So far, no smoke event this year, but it's definitely early yet.
Well, we'll be really interested to see your data during the next event. We can compare notes. We'll compare my house with your house. PM 2.5 and CO2 levels. That'll be interesting.
But it really depends on how long it lasts, because I can shut down all the house as much as possible. And that lasts okay for like 3 days. But after that, man, it just gets uncomfortably hot.
Yeah, at least we're lucky it's not hot right now. I think that would be really bad if we also had some heat with this.
Well, and then imagine if the power goes out. I think all those things together is what I'm like when we think about the challenge of passive survivability and the resilience of our houses. How let's picture that event, because it'll happen when all these things are aligned. And how can we make sure that we can be healthy and be okay during those times? And I think that's when like the building envelope becomes really important.
I was really surprised how much it really affects your body, basically, because I've never experienced this before. So just having burning eyes, but also really feeling it in your chest and your throat the whole time. Yeah. I'm sorry that you have to endure that more often. It's
also emotionally draining, because it looks so freaking scary outside. Oh, yeah. It's like,
that was a comment someone was making, that orange color, it makes depth perception tricky, and it just has this really weird scene because it's just not right, and it, mentally it does something to you.
The good news is probably by the time that this airs, the air in where you live, Ilka, and in New York and stuff will have cleared up, and that is a wonderful feeling when you can actually go outside and see the blue sky and breathe in, and it'll happen.
Yes. Anyway, well, thinking of you guys, and that is, it's sobering, and also to think, and I agree, Zach, that it's a question of when it happens again, not if, and that brings into mind all the important strategies to be able to cope with those, but also things like filter changes and adding filter systems like you've done, Mary, to your ventilation system, and just what we might need to change and from a design perspective. So anyway, let's move on to today's great interview, because we've got a repeat guest who's doing some fantastic stuff. But before we get into that, let's do a quick thanks for all our supporters, Zach.
Yeah, let's do. So just a reminder that this whole project of transitioning to buildings that are clean and resilient depends on partnerships with innovators who are making the products and the components and the materials that allow us to create healthy buildings. So a big thank you to our founding sponsors, 475 High Performance Building Supply, Baxt Ingwe Architects, Glavel, Minutair, Mitsubishi Electric Train HVAC US, Partel, Rockwell North America, Stocorp, and Zola Windows. Thanks to our champion sponsors, Bewizo, Gradient, Icon Windows and Doors, Intelligent Membranes, PH Air Seal, Proseco, and Source 2050. And a big thanks to our stakeholder partner, NYSERDA, the New York State Energy Research and Development Authority.
All right. Well, we have Katie Faulkner back with us. So back with Mary and Ilka this week. And Katie's been on the show before. I think you said, was it episode 37, Zach?
Mm-hmm. Yep.
And doing some fantastic stuff, kind of bringing some of my three favorite topics together, which is retrofitting, passive house, of course, and prefabrication. By themselves, all quite challenging. Put them all together, and it's even a bigger challenge, which Katie and her team are doing some amazing work on. So this chat, Mary and Ilka, you started out. We started out with a conversation that you had a sort of follow-up interview, but crossing over also to where were you, Ilka, when you caught up with Katie?
Well, I was actually at the NASI conference in Boston, and I had reached out to her because I had met her in Boston like several years ago. We just keep staying in touch. So I reached out to her to connect again, and she actually invited me to the Autodesk Tech Center, and that's where she is developing and building the prototype for her panels. So, and that was luckily right around the corner from the conference. So I went to visit her, and it was a really great experience. So I decided to just interview her right there and then.
And I'm very pleased that you did. So that's coming up towards the end. But first, let's hear your chat, Mary and Ilka, with Katie Faulkner.
Hey, Katie. Good to see you again.
Hi, Ilka. Nice to see you again. Hi, Mary. Nice to see you.
Nice to see you.
So we actually had an interview with you a while back where you told us a little bit about your background. But as a refresher, can you talk a little bit about yourself and what you've done so far and what you are doing right now?
Sure. Happy to. I am an architect by training. I've been practicing and licensed for almost 30 years, which is scary. I probably said that last time too, because I still can't get used to it. I have worked for a number of different firms of different sizes, and then recently was one of the founding partners of NADA, which is really Nadir Tirani's firm, successor to Office Don. We had 9 years there, which I enjoyed very much, and then left in 2019 to join Katerra, mostly driven by ambitions to make construction and architecture more sustainable. I think a lot of us who joined Katerra at that time were really driven by their promise to streamline the production, cut out the waste, make it easier to control costs. And I still very much believed in that, although the story of Katerra is probably the subject of another podcast. And that didn't last more than about a year. And then in 2020, I found myself kind of unceremoniously out of work and thought that would be the right time to launch my own practice. And so I launched Westwork out of my son's bedroom. And one of the first things we did was a design competition, something called the Triple Decker Challenge. And that was an opportunity to work with Mass CEC, Clean Energy Commission, which is kind of our version of NYSERDA, which is really a clearinghouse for a lot of clean tech. And they have been tremendous supporters of ours. But this was a design competition, particularly looking at deep energy retrofits. And that was really the first time that I did a kind of a dive into the finances of how that works or doesn't work. And sort of without dragging you through all of the minutia of how we got here, in 2021, we took our runner-up winnings from that and we launched HP Tech to look specifically at how to do a bio-based retrofit panel that would improve the energy performance of these existing kind of mid-rise multifamily by at least 50%. And we have been working on that both as Westwork and then more focused as HP Tech almost for 2 years. We got some grant funding from the state. We got a nice grant from the Department of Energy, which has come to an end. And we are waiting with fingers crossed to see if we get the next phase of funding, which would allow us to scale it up a little bit more. When I saw you last, Ilka, you joined me at Autodesk. We have enjoyed being at the Autodesk Tech Center in Boston for a year. We now have 4 people working down there pretty much full time, and we take advantage of the tremendous software and tooling that they allow us to use. And really, without that, we wouldn't be able to develop some of the prototypes I shared with you. So here we are.
Yeah, that was definitely an amazing tour that I got there. And sorry, Mary, that you missed it.
Yeah, I'm sorry too. I would love to see it sometime. I just wanted to hear a little bit more, and we are going to jump into that interview there on site at the Autodesk Tech Center. But before we do, can you talk a little bit more about the building type that you envision your panel being applied to and under what circumstances?
I can. And that we think a lot about that. We come back to it often, but it did start specifically at looking at triple deckers and focusing on multifamily wood frame buildings. So that is not necessarily ubiquitous, and in other parts of the country, it's less of a concern. And oftentimes when we show the work that we've been doing, we're asked if this is translatable to other building types. Can we scale it up? And the answer to that is yes. I mean, it would certainly be possible for a single family home, but it is because it's the wood fiber and it deals with the sort of breathability and moisture management. It really is meant for wood frame buildings. The system that we've developed is actually a clip system, and in our IP, our intellectual property is in that system. So the panels themselves could be something other than wood fiber. But there are 2 things we were really trying to wrestle with. One is that there aren't very many, if any, options to do exterior insulated panels that are made out of anything other than foam. So it was important to us to investigate those options. And there aren't a lot of options available for this scale of building, this kind of missing middle of housing that go up easy, that are inexpensive, easy to handle, and generally lighter weight. So that's the market we have focused on. It is not to say that the systems that we've developed don't have other applications. For example, some of the materials I showed Ilka have actually pretty solid applications for interior use. They would be quite beautiful. The material of the wood fiber is really quite lovely. It can be carved. It's got kind of a beautiful through texture that is, the beauty of wood, but different. And so there are applications like that. But as an architect, we often contend with the need to upgrade energy performance for subsidized housing, for example, and some of the funding that these projects have available to them is contingent on their ability to improve their energy performance. And so there's a need, in our opinion, for this approach for that size of building, because there are not very many ways to get to that level of performance, again, without a well-insulated envelope. So we think it's kind of a combination of both a market need and a time to look towards more sustainable materials.
That's great. And you mentioned that these were lighter than average panels than other panels that are on the market, which I would understand means that you can maybe get those into place without craning, which would be a huge advantage. Is that correct?
Yeah, actually, that is quite deliberate. When we first started this, like many people, we thought the solution was in the large format mega panel. We were looking towards energy sprung, and we were looking at 10 by 20 foot panels that would be craned in. We actually had the opportunity to try to build them at a site in Roxbury for a project that we had been working on that we knew was going to be torn down. And right away, we had to deal with the expense of a crane and the challenges of getting them into these really tight urban sites. It just wouldn't have been practical in either case. So we moved away from the mega panel and we moved away to kind of vertical siding towards horizontal siding. So the pieces that we work with tend to be about 24 inches tall by maybe 10 feet in length, 8 to 10 feet in length. And then they can snap in to a substructure, which was kind of a new development. We initially thought we could sort of hang them directly with monarch clips, and that became really hard to do with a big panel. But without going into too much detail, I think that we felt like the smaller size gave us some flexibility to deal with A, the irregularities of existing wood frame buildings, B, the kind of ability to handle it, which we wanted to make sure that we could deal with. We also thinned the panel up when we initially started. Wood fiber panels can be quite thick, and you can get an R value of, R18 out of the panel itself, but that panel will start to get quite heavy. So our panel has now been thinned down to about 40 mil, and then we have a backup layer of mineral wool, and getting kind of in a sandwich to get that R value, because the thick panels, they're both heavy and they're somewhat unwieldy to deal with on those transition details, windows, corners. Kind of every time you make a plane change, like a bay window, thicker panels become inelegant pretty quickly.
Great. And what about the pre-installation process? I mean, one of the issues that people talk about in retrofitting from the exterior is just how to get the building information data from the exterior to plan the panels. Is that something that you're addressing, or are you figuring somebody else's software is going to address that?
We are trying to address that in our next stage funding with DOE if we are so fortunate to get the grant. We've lined up a team to look at taking the information out of the LiDAR scan and really diminishing the point cloud data to the more essential points that you need. I think anybody who's handled a point cloud can find that to be really heavy, and there's a lot of potential for human error there if you have just too much information. We take an approach where the building should be taken down to the sheathing and actually have the vapor barrier, or air water barrier put up for scanning. That gives us a kind of a nice smooth canvas to do the scanning. And then from that, we're dealing with some proprietary software that helps us optimize the layout in a 2D format. Where the challenges are at the moment is taking that scripted software configuration that works well with a CNC and moving it towards a larger scale fabrication. Because what we'd like to be able to do, we've always talked about this scan to skin idea, that you would be able to move relatively seamlessly to getting the digital data, optimizing the layout, moving towards this kind of CNC cutters, and just making sure that the whole thing runs through a fairly automated process and there's minimal labor. So that when you finally do get on site, the application and the installation is easy.
And you mentioned intellectual property, and I imagine that this is a bit of a new process for you.
Oh yeah.
How was, I mean, you must have had to file a patent of some sort, right? And how was that process for you as a relatively new endeavor?
So we're still in it. We do have one patent pending, and that is about the clip system. We have been trying to figure out a way to patent the configuration and coding of the panels, because we've spent over a year kind of optimizing that process. At the moment, we're not yet clear that that's patentable. So it is an interesting process to try to understand what is and is not patentable, what it means to have a patent pending versus a full patent. So I'd say it's still a work in progress to help us understand that. I think we're of two minds. On the one hand, we think it's very important to protect the intellectual property. Otherwise, it's going to be difficult to kind of commercialize this. I think no one will be interested in something. On the other hand, we're so anxious to see its applicability that I think the patent process frustrates us sometimes as well. That, we're really quite anxious to have it, people adopt it, use it, try it out. As you know, when you take a product to market, there's a whole host of testing, ASTM testing, NFPA testing. We're not going to be able to introduce this to the wider market, but we could potentially put it up on buildings and have it monitored, which is what we're in the process of preparing for right now. But going through all these stages takes time. And I think we are all three in agreement. We don't actually have a lot of time. So we're hoping to find solutions within this approach that are more readily available, more market tested, that help people deal with the deep energy retrofit in an affordable and easy way. So there feel like there could be many outcomes of the process. And when I think in terms of a kind of 5 to 7 year process, I'm just not sure, 2030 is, coming fast and soon. And so we're anxious to find ways to get it up on buildings and test it now.
So do you have a plan for testing out the panel on an actual building? And if so, can you talk about what type of building that is or the situation there?
Yes, fingers crossed. If everything falls into place, we have identified a triple decker for a temporary installation, not unlike the one we did 2 years ago, although in this one, the building is not coming down. But we have already scanned the building and we've already started working on the panel layouts. What's holding us up right now is getting the funding to actually buy the materials. It's a lot of wood fiber, and it's literally hundreds, if not thousands of clips. So the cost of actually making the system is more than what we've been doing. As Ilka saw at Autodesk, we have this kind of one armature that we continue to test mock-ups on, but frankly, you could fit it on the back of a truck. What we're talking about doing now is at least 2, if not 3 sides of an existing building, and then putting monitors on it and kind of watching it for the 12-month cycle. That is kind of funding contingent. So if we do get the funding, then we're ready to kind of go all steam ahead. If we don't get the funding, we'll be sort of looking for another way to support that project. You mentioned that because I'm talking about this as if it's just me, myself, and I, which it is not. Evan Smith of Place Taylor was an early partner in the design competition for the Triple Decker Challenge. In fact, we wrote a piece for the Passive House Accelerator about that because we were so impassioned about this idea that if we could come up with a solution to retrofit, then I think that would get us a long way towards energy improvement, and then the electrification is a lot more effective. We then took some of our grant money and hired a third person, Kristen Borger, who had been a colleague of mine at NADA. I'd hired him out of school at the Boston Architectural College to help me launch NAD Lab, which is a fabrication arm of NADA that still is an ongoing concern. And we had done a lot of millwork installations, and we were really focused on the kind of abilities of CNC technology and to move from design to application to installation and kind of, again, minimize waste and sort of shorten the cycle. So the three of us, I think, are united in our belief that the cycle of design to construction can be shortened, that the elimination of waste is really important. And then there's probably nothing more important than contending with making more efficient the energy consumption and needs of the building sector. So it is true, there isn't all three of us, Christian and Evan and me, but at that time I was talking about the three of us here on the call.
So, and then you're talking, and that's what I saw to the mock-up at the design lab there, and that's what you are making yourself, right? But then you're talking about using or making bigger panels for actually buildings. And I know that we talked about manufacturing, and you said we don't want to be a manufacturer.
No.
So how is that going to work? Who's going to manufacture the pieces? Because you have basically two systems, right? The clip system and then the panels.
We will manufacture the pieces for the early applications. I think we are prepared to make enough panels to cover as many as 3 buildings if all of the projects we've lined up fall into place. Let's assume 2 out of the 3 do. We will make those. That is a big lift, but it's definitely doable as attested by the work we did at NADA. These sorts of fabrication exercises are onerous for someone who has a CNC, but not impossible. That is not a sustainable model, no pun intended, for an actual commercialized product. It's just too, you can't move them fast enough. You can't generate enough material to do the work. I think, again, and I speak really only for myself because I know Evan has kind of different ideas about how this could go forward, but I did never imagine myself in front of a panel company. I mean, Westwork is a really important part of the work that we do, and the team that we have here has a very similar agenda in terms of designing energy use kind of applications for the built environment in an elegant way. And so I'm very close to that. I do not really understand, and I know I've said this to you before, that I see the kind of light at the end of the tunnel. We've had a lot of interesting meetings with building manufacturers, our building material manufacturers. We've talked to people at Saint-Gobain. We've talked to people at kind of the helm of some other larger companies to try to understand how this works. When you are designing something that needs to be tooled up from zero, that's less attractive to these companies than could sort of just already make it. So there are a lot of questions there that I don't have answers for, but I do think that we could come up with an approach and show that it's feasible and cost effective, and then hopefully license it or have someone else take it over. And that would be my goal. And then maybe we move on to another problem.
Great. And one minor question. You mentioned, that's a lot of wood fiber. And the sourcing of that, do you anticipate, are you experiencing any problems with that?
Yes. So when we started the process, we really cast a wide net. We were looking at mycelium, we were looking at hemp, we were looking at foams that promised to be more sustainable. We looked at hay. I mean, we really kind of explored quite a bit, particularly in the triple decker challenge, but even maybe in the 6 months afterward. Having done that, and also having worked with wood fiber before with some projects that were being done with Benson wood, we felt like that had the best promise to be readily available in the near term, but it isn't readily available in the near term. There really are only two manufacturers that make it at the volume that we need, Steico and Hutex, both in Germany. Timber HP out of Maine is launching a factory, or actually I think they have already, that can produce the fiber insulation in more of a bat or a fluff form, and promise to move toward a board form. And we have every confidence that they will. They were ahead of us in this process, and they've, I think, been really diligent about it. That being said, that still isn't foam, which, you can get 5 ways till Sunday. So it is always going to be an issue about the kind of ubiquitousness of the material, but we felt like we could only start with kind of our best bet with a process that looked like a biodegradable and potentially recyclable material. Wood fiber, I think, has the best promise for that. Our panels do not necessarily promise to be recyclable because they do rely on coatings, so that it's just the panel and not a series of lamps. So there are a lot of questions about the circular economy. Ours is not a perfect approach, but I think that if we are looking at alternatives to the foam products, we still believe that the wood fiber has the best potential. But you're absolutely right, Mary. It's not like we call up 5 different sources and bid it out. Our whole cost model depends on the fact that it is more readily available than it is now, if that makes sense. In other words, that we're looking at some future where wood fiber is a more common material that you could pick up at a big box store, which you can't right now.
Okay, well, let's listen to the on-site interview that Ilka conducted. And afterwards, we continued to talk about how to keep her panel venture going.
I am in Boston right now for the NESI conference, and you invited me to the place where you are actually developing your panel, the Boston Technology Center.
I am very proud to have residency here. Autodesk had what they called the build space about, I think it was about 10 or 12 years ago that they opened it up down here in the design district. And this was well before this part of the city was really developing. So they were really taking a chance out here, and they put in possibly the best fabrication shop within hundreds of miles, to the point where MIT and Harvard and some of the big universities that have their own fab labs would still come here, because Autodesk had really invested in some fantastic digital fabrication equipment, so that we as architects, so that innovators and entrepreneurs could come down here and experiment. Of course, the undercurrent was that we were also using Autodesk software, although that's not required. We do use it, but we also use other software as well. When we had the opportunity to get a little grant money to develop a retrofit panel, we wrote an application to become a resident at what is now called the Autodesk Technology Center, and it is now part of a network, a global network of technology centers, so that you can both be here in person or work from afar and use, again, their growing collection of digital fab equipment. For us, it has been about a year. We are developing a wood fiber-based retrofit panel, and we are taking advantage of their vacuum forming, their shaping, their multi-axis CNC routers, their water jet tables. All of these things are at a scale that allows you to prototype at full scale. And so we are thrilled to be here. We hope to stay another year and continue to use this great facility.
Yeah, again, this facility is very impressive. Should be a lot of fun working here and figuring all these things out that you have to figure out. So and I just saw a big mock-up of your panel, and maybe you can talk a little bit about the build-up and how you got to make all these decisions that you've been making.
Sure. We started the idea after having done a Mass CEC-sponsored design competition called the Triple Decker Challenge, which was looking for a business case to do deep energy retrofits and basically electrification of the region's triple decker, which is a multifamily housing type, which is very specific to New England, but is essentially a 3-story building. We still have thousands of them. They tend to be uninsulated and almost inevitably are either gas or oil fueled. So we came away from that realizing that electrification on its own is not going to solve a problem, because now you're giving heating and cooling to buildings that haven't even had the cooling before, and that is going to put an incredible stress on the grid. So we started looking for really sustainable ways to handle the envelope. We started with foam, we started with different systems, but we ultimately developed a prototype for a wood fiber-based insulative panel, which could be overclad on a building with a tight envelope. We're very excited about wood fiber panel. This is not a common insulation product in the US. It is very common in Europe, as you know. There are a couple of manufacturers that do tend to participate in the market here, but we're extremely hopeful that will become a popular product. And we like it not only because it's wood fiber based and essentially carbon neutral, but it's relatively light, it's easy to work with, and because it's wood, it can be treated to be the final surface. So we're not building panels up on site. We are about a year into a DOE grant that we won, and we have been developing a system of drop and lock panels that can go over clad buildings. We will continue to work here at Autodesk, but in about another month, we're going to go back outside and put these on a couple of real buildings and see how they behave over a 12-month period.
Yeah, so I was really curious. It was really interesting to see how you treated the panels to become watertight and just being a finished panel. Can you talk a little bit about the different options that you've looked at and what stuck and what didn't?
Stuck's a good word. So when we began the process, we assumed that we would be going with a cementitious coating, and we actually invested quite a bit of our own money in a particular kind of spray pump that would allow us to spray a very thin coat of cementitious product on these panels, which could be shaped, and so we could make them look like clapboards or shingles. And then with this overclad, couple of issues with the product with cement that didn't seem to work well. There's a real difficulty in controlling the thickness of the layer, and there's also some challenges with using it on the wood fiber and some delamination. I still think there's a lot of potential to use a cementitious coating. We haven't completely ruled it out, but because we're trying to hit a very affordable price point, we moved to an epoxy finish. We moved to a very thin coat that's applied on a vacuum table that gives a very nice finish and then ultimately could be painted. That allows us to control some permeability, which we think is still important in the panel. But again, a lot of this has to do with the actual cost to produce the siding product, its performance as far as its durability and how it deals with moisture over time. And then again, the actual R value that we're going to get for it. So at the moment, I'd say after about a year of testing, we have left cement products off to the side and are really focusing with variable mixes of epoxies, trying to get the right perm rating, the right finish, and then ultimately that is likely to be covered with a coat of paint.
So the one coating that I was really impressed with was the fabric. I guess that's the architect speaking.
Yeah.
What is that?
We have a beautiful sample, and I think that this as a product could still have real potential as an insulative material, but probably not as an exterior material at the moment. We found that by just using a kind of a canvas or even a burlap, that can actually be adhered to the panel, because the panels tend to have enough tooth in them so that they can really take it, and then put a finish coating on that gives a very kind of glassy sheen. And on top of the fabric, it's beautiful, and you can use any fabric. I think that has real potential as a product as well. We continue to look at that as a sample. For the moment, we're developing an exterior cladding product that kind of deals with a specific problem in our region. But as an architect and someone who can appreciate both the beauty of the material and the kind of potential for future use, I think that the fabric laminated with the finish has both the potential to be kind of highly performative, both acoustically and temperature-wise, but it just can be absolutely lovely. And so we haven't given up on it. I think that it's kind of off to the side as sort of one of our products that was a collateral development in our journey.
Yeah, I'm really hoping that you're not giving up on it. It's beautiful.
Thank you.
So what are the next steps for you?
So we are back into grant writing season. So I'm an architect by training, as you are as well. And so it's interesting how we come to these journeys of this kind of do a design competition and think, well, I can develop this as a product, but not really ever wanting to be someone who owns a factory that produces panels. We have come to this position primarily through the generosity of both the state of Massachusetts venture grants and then the Department of Energy. We had a small grant. It is now grant writing season again, and we are very busy putting out proposals to look at a couple of things. We are continuing to look at how the panel behaves under stress. I mean, over time, extreme cold, extreme wet, extreme heat. Ultimately, we have to bring it into fire testing, NFPA testing. So that's kind of one bucket of things that we're doing to just ensure that this as a product is going to be a good and safe and clean product for the decarbonization of the built environment. And that's really been our mission at the forefront. The second arm of this, of course, is to show that it's a commercializable product, that it can be produced at scale. And that means it is something that is performs very well but is extremely inexpensive. That if we develop a product that is high performance and is so expensive that just normal people can't use it in the course of maintaining a building, that will not get us to where we need to be in the short term. So both of those legs, I think, looking at how to scale it up in terms of production and ensuring that it meets all of the industry tests that are required for an exterior construction material, those are the things that are keeping us busy these days. We're very excited to be part of the ecosystem that you're in, that people that are pushing a passive house agenda, that understand that there is no time to waste, to the point where this really is a collective effort, that this isn't the situation where we're sort of hope to be the first one to get to the end of the line. We truly believe this is not going to be successful if we cannot develop cohorts of expertise, grab the people that are very passionate about FIAS, about passive house, about electrification of buildings, about building science in general, and really begin to develop some products and some processes together, because it is not just having a good idea that's well designed. It is the ability to execute it, is the ability to manufacture it, is the ability to navigate the various codes and laws that are in place that allow us to do these things that are different. None of this is going to be able to happen within the next 10 years without extraordinary collaboration and cooperation. So I'm really pleased you were able to come down here today. I'm really happy that you're in town. I wish you the best in your own product development and really hope we have the opportunity to do something together.
Yeah, thank you so much. Thanks for inviting me. This is, again, very, very exciting space.
Thanks for that on-site interview, Ilka. Then I had a couple of follow-up questions. That one is about you refer in the interview to your whole grant process, which obviously it's changed since that interview, and you talked about it just now. But I just wondered if you wanted to address in any way the challenges as an innovator of, having to suddenly become skilled at grant making, applying for grants, and whether, and something that I'm kind of curious about is, as an innovator in this space, are you finding that the IRA has unlocked new funding sources for you?
Two answers to that. One, I feel indirectly that it may have, because I do feel that there's more buzz around this kind of work and the potential funding that is available. Have I actually seen it, and could I trace it back to IRA? No. But where I will say that I'm feeling it is in the architectural work, particularly again around the subsidized housing projects that we're doing. That funding, LISC, LEAN, some of the other grants that they are seeking is contingent on improving energy performance. There are local grants, there are state grants, there are national grants. That, I think, one probably wouldn't have to pull too hard at the thread to be able to tie that back. It is a confusing landscape. I've been to a number of presentations and logged on to a lot of lunchtime discussions where we try to unravel the path forward. And it's pretty new. We're talking January 2023, where most people have been trying to balance this. It is certainly easier to navigate around housing, much more challenging when our clients approach us for libraries or schools or other buildings where you kind of think this should be available, but yet we can't quite figure it out. So I think that, yes, I quote unquote feel it, but most of the funding, all of the funding really that we have sought has been in really well-established channels. State venture, Mass Venture has been supporting clean tech innovators for a long time. Mass CEC has been pushing this agenda for a long time. And the DOE SBIR program has been around for a long time. Maybe they have more funding now than they had. Maybe more grants will get funded than might have in previous times. I'm not kind of privy to the numbers. We did apply for 2 of them this year, not just one. So we were all geared up to apply for SBIR 2 in April, and that's a really heavy lift. And then somewhat out of nowhere came another grant that was really focused on panels. That was an equally heavy lift. So March and April were pretty tough months. I suspect that second grant, the one about the panels, again, has some direct ties back to the IRA money, because it was really specific about energy production, reduction of use, efficiencies, price points for products, kind of ease and availability. So it was obviously very practical. So, I mean, that's what I can tell you without having hard data.
Well, good luck with all that. I mean, it's so many new roles to take on. Kind of getting away from your training, your background and training.
I don't know. I feel like the grant writing intimidates a lot of people, but honestly, it's kind of one of those things which just is about endurance. There are forms, and then there are sites where you register, and then you have passwords and logins. And it honestly, it's not, people like rocket science or brain surgery or whatever. It's not, it's not necessarily like that you have to be special. You just kind of have to have like endurance for it. People are generally well-intentioned, and the rules are written out in about 5 different places. You just have to kind of stick with the process. But I see a lot of young people with these sort of ideas, and there is funding available. It just does take you really have to commit to the time. It took us a long time to get that first grant out. Now that we've done a few, it comes a little bit easier.
Well, that's great. I hope that you are successful in pursuing it, because
Thank you. I hope so too.
Yeah, I see this technology is super important, because there's so many existing buildings that are out there, and I love the flexibility in your system. The smaller buildings need to be retrofitted, and by smaller, I mean 3 stories and under.
Yeah, I think our hope is that if we can get it up on buildings, then the applicability of other construction types, other building types, that becomes, people can see and envision that. But when it's all sort of in a drawing or a 3D model, or even on a kind of a mock-up in Autodesk, it's a little bit harder to convey. So this next year will be very important. If we can get it up on buildings and document it successfully, I think that will carry us to a new stage, which would be wonderful.
I have another question about your panel, since you just talked about circularity and recycling of the panels or the building material. What do you think? Do you have any estimation on how long the coating is going to last?
So part of the durability testing that we are doing with Oak Ridge National Labs is just at that, looking at the coatings. The building, the material is not only coated, but it's painted. So it will depend on maintenance. It's somewhat like siding on a house. If you had wood siding and you kept it up, it could last a very, very long time. We are running models that take it through kind of the first decade and the second decade, and we're not really seeing degradation of the panel itself. But you're right. I mean, the use of it in this environment is not well documented. There are cases where it's been an exterior material in other countries, and we're trying to tap into some of that data, but that won't necessarily put us in good stead for our own ASTM testing. But we do have to demonstrate that. We have to demonstrate, again, the hydrothermal performance. But again, we just call it durability. How long is it going to last? Will it be able to hold up? And that's part of the getting it, we're using their wonderful testing chambers in Tennessee, but getting it out in the buildings in Boston and actually putting sensors up on that, I think will help us read that as well and get a better sense for, is it going to hold up, and how is that? And there are loads of coatings. We're looking at primarily their epoxies, but there are many, many epoxies. So we are running a lot of different tests.
Yeah, because I'm thinking that your system lends itself to being reused, right? If the coating keeps up. So even though you can't really return the panel to just being a wood fiber panel, right, you could, if the coating stays on for a long, long time, the panel itself and even the clip system could be reused in the next building, correct?
Yeah, I mean, these are the huge questions that we often have student groups come through. We host a lot of tours, and that's part of the bonus of being at Autodesk, is you get to meet a lot of people, and there are other innovators there as well. And that question comes up all the time. This idea of, can you recycle it, of circular economy? And these are questions we can't answer. I mean, we are a very small team, and we are trying to kind of manage the hydra, or the decision tree of all of the options. But I think that's one that deserves a lot of attention. I think what Timber HP is proposing, and rightly so, is that the material, when it's in a board form, can theoretically be ground down and turned back into the fiber. And so in that way, the product is quite circular. Once you take it, treat it, cut it, kind of work it, what's the word I'm trying to say? It's like, adding a lot of ingredients, and suddenly it's a, candy bar instead of something else. I don't know. I think that our feeling is that it isn't going to be likely a perfect product, particularly on its outset. For example, the clip system, those clips are plastic, and we're looking at using recycled materials to do that. But the plastic gives us the benefit of not being a thermal bridge, having the flexibility of the bend that allows us some forgiveness when we're trying to deal with an existing building. But, again, not all of those materials are things that you want to eat for lunch. So that we think a lot about that. And I think these are questions that we're going to have to contend with in the next year to 5 years. What is the message that we're giving with the panel? How environmental is it?
You mentioned testing at Oak Ridge. How did that come about? How did you get them to be testing your panel?
We've written a lot of grant applications, and one of them I found out about through one of our collaborators, SNYL, who's our envelope engineer and structural engineer on one of our early grants. does a lot of work with various kind of facades committees. And Oak Ridge National Labs has a grant of about $100,000, which is just an in-kind grant. In other words, there's really no money that passes hands. That it's an 80-20 split or thereabouts, where we're doing 20% of the work, the testing, the preparation. We kind of design the program, and then we work with them to find out what we can buy from their services. So we wrote a proposal, which took about another. These take a lot of time, but we wrote a kind of a white paper, sort of, I guess, what's the word? It's like a letter of intent, made it through the first gate. That turned into a one-pager, which made it to the first gate, which came in as sort of a full proposal. With the first DOE grant, we went after a lot of matching funds. Some we got, some we didn't. We went after some supplemental grants. The Oak Ridge grant was one of them, and that helped us cover things that the first DOE grant didn't, like the testing. We can do energy modeling ourselves, but we don't have chambers. Autodesk does have a sort of an interesting environmental chamber, but it isn't really appropriate for what we're after. So we have continued to pursue work with ORNL's BOT, our BTO, their Building Technology Office. Some of the grants going forward have written them in hopes that we can continue the work, because they really have the facilities that we need to do this kind of testing. This is not something that normal people have access to.
Right. Yeah. Congratulations on getting that. I'm sure that's a huge hurdle.
It is a huge hurdle. I think the message to other people that are interested is that there are just so many resources available, and there's a network of people, again, that have the will to make it happen. There's all kinds of work that Rocky Mountain is doing with their their ABC program. There's a lot of good work that's coming out of DOE. There's a lot of work coming out of sort of these. It is just again, these things all take time, and most of us have kind of other jobs, but it's very rewarding to kind of be able to tap into some of these things, because pretty much everybody is after the same thing. So while we see market opportunity to do so, that isn't usually the primary engine. So if you can begin to find these collaborators, I do think that there's something good will come out of it. As I said to you earlier, I don't really see the end of the line, but I think the journey, my hope is that will shake out some really interesting collaborations. So yeah, I mean, we have discovered some of these things by accident, and some of them through networks like the one that we've developed through the PH Accelerator Group. I mean, many of those people are sort of the same people that we see at conferences and webinars.
Oh, well, congratulations for all of your progress on this, and making this idea become a reality.
Yeah, and I'm sure we'll follow up again with you in a year or so to see where you are with your panels then.
I hope so. I hope I have news for you then, and we're moving a little more quickly. It feels like we're moving quite slowly, but
I'll definitely come and visit you again, though.
And that was Katie Faulkner of Westwork. And great conversation there as well with your in-person chat, Ilka, which was fantastic. Well, let's go straight back to you, Ilka. But from the previous conversation we've had and the work that Katie's been done, what was sort of excited you most about your recent conversation?
Well, I think just in general, it's great to just keep checking in with her, and it's just great to meet these people that you actually stay connected with, so you can follow their progress. So back then, I think the first interview that we had with her, she wasn't really even sure what kind of material she was going to use for the panel. I think the only thing she knew that she didn't want to have a panel that's built out of foam. So now we know that she decided to wood fiber, and what's special about her panel is actually that she's using the wood fiber insulation and applies the coating directly to it. So I feel like that's something that is not really that common. So I had the chance to see the coating, the way they attach the panel with this clip system to the facade or to the current facade. And then they played around with different kind of coatings. And one of them that really fascinated me, and I talked about it in the first interview, was that they applied a fabric. So that was really, really beautiful. So I hope they're going to develop that a little bit further as well. But in general, I think the idea of just applying these coatings directly and just, doing all the testing to see how it holds up is just quite interesting. And I'm curious how they're going to progress with that.
That struck me about the number of changes in design that they'd gone through, and that Katie was also very open about. And it seems it went in with fairly open mind, but also some ideas which have completely changed, like going from mega panels down to a smaller unit. That they were fairly convinced they were going to use cement, and then they changed to a different system of weatherproofing, changing from horizontal versus vertical. So that impressed me because it shows that they're very open to doing the research and figuring out better ways, not being necessarily stuck on one particular solution, but looking at the bigger picture. Mary, what about you? What stuck out for you?
Well, I just am very appreciative of the whole approach that she sees this problem that a lot of people see. I mean, everybody knows that retrofits have to happen, but and has just gone about in a practical way saying, I want to contribute to solving this problem. Yeah. And targets a particular type of building. And as you say, there's been a lot of kind of pivots in what they're designing and the product that they're designing. But I just so much appreciate the intention of what she's.
Yeah, I really like that idea that they seem to be grappling with of making it commercially viable, but also scalable, and not necessarily them having to own the factory. That then she's not approaching it from. I think she said it explicitly that she doesn't want to be own a factory of panels. But they're interested in making a system that will scale. And I think that's the key for getting this type of thing up and running is having compatible components that will work together. Because otherwise we'll just end up with every person designing bespoke solutions for every single building, which is not going to work at the speed and at the scale we need it. Zach, what about you?
Well, it was really an inspiring interview. I think that she's tackling this critically important. I was impressed by just like this clarity, purpose, and how that is, I think, helping her to navigate all sorts of complexity in this work that she's doing, whether that's complexity around the market or supply chains or governmental regulations, or just the point cloud when she was bringing up the point cloud and I'm no expert in this, but my understanding is that when you do one of these imaging exercises of a building, that you are presented with a cajillion points of data because the buildings, like the as-built condition of the building was not perfect to begin with. The building maybe settled over time. Maybe there were some weird failures here and there. So what you imagine to be a nice flat rectangle is instead this mass of crazy little ins and outs, and those, each of those is a different data point. So being able to cut through the noise and figure out which of those data points are the important ones, and then respond to those in a way that you can do in the factory is just so critical. The promise of being able to do this kind of work is so great. So I was inspired to hear her talk about how they're tackling these different challenges. This is what's exciting about being part of this community,
Yeah, I mean, there's so much potential and need there for collaboration to look, because it is a whole system approach. I think anyone who's done any remodeling or renovation that can definitely, picture and they've experienced how hard it is to measure things, because nothing's square, nothing's straight in an existing building. That's part of the problem. It's all well and good. We're trying to modularize and make things out of a factory, which is all about standardization, but most existing buildings aren't standard. So you have to have something that's scalable, but also flexible enough to cope with reality. Lots of challenges there, and I agree. Some really exciting stuff. I'm interested in the evolution of wood fiber insulation panels, and I think this is something that's being explored in this part of the world as well. And Katie did mention Gutex and Styco. They're the two brands that I know of as well. So I was a little bit surprised. I thought that the industry would be a little bit more advanced in North America, but it seems that we're all playing catch up a little bit with Germany at the moment.
Right. I think there is also another wood fiber manufacturer in Quebec, but right. I think it's that she didn't mention it because I think that maybe they don't deliver outside of Canada. But Timber HP, we've been, all excited about the promise of Timber HP for a while. And it's just, every innovation takes time.
Yeah.
Well, and it's easier to fabricate the bats and the loose fill first. So I think that's what they're rolling out right now. So the panels are going to be probably next year or the following year. So we're all awaiting it, but it's not ready yet.
Yeah. And just finally, I want to comment on the process of grants and getting funding. This is something that I get the impression that Katie didn't set out to do as an architect, but has found herself in that space of getting good, improving the process, and realizing that there is funding out there. There are pockets of money that are people are putting up, and whether it's in-kind time or whether it's actual cash to buy materials and do research. And I think that's something that people should look out for if they do want to innovate and create something that they think should exist. Then reach out and see what's available, and you might be surprised that there might be pockets of money and or other parties that are willing to invest to create something new and change a process or create a new process that needs creating. Awesome stuff. Any final thoughts?
Well, I think for me, what was interesting, and it came up towards the end, was the idea of the circular economy. Like, how do you reuse material, and how do you make that part of your design decisions as well? Because she said, well, as soon as we put the coating onto the wood fiber insulation, you can't really return each material to the original state. And therefore it's a different, it's a little difficult to talk about circular economy that way. And I think it's just very interesting once you start thinking about it. If that's your goal, you really have to base every design decision towards that goal, basically, because as soon as you adhere one material to the other, then you can't really reuse it that way. So in terms of, when we think about assemblies, for example, a liquid applied, air barrier might have different benefits than a membrane. A membrane you can just separate from the assembly easier than a liquid applied. So I just think that thought process is quite interesting.
Yeah, absolutely. And it adds a whole nother level of complexity to the whole thing, but very important as well.
Yeah.
Awesome. Hey, well, thank you as always, Mary and Ilka. Great that Ilka you could catch up in person, and really enjoyed hearing again from Katie, and look forward to watching the progress. And hopefully it's not the last time we hear from her. I don't think it will be. We'll see where that goes, and other ventures like it. Alrighty, Zach, what have we got coming up at the Accelerator and around the place in Passive House world?
Yeah. So, well, first I'd like to just give another thank you to Databased Plus. They are our Passive House Accelerator partner of the week this past week. And so they made our programming possible this week. So big thank you. This next week, we are joined by Kara Haggerty Wilson of Onion Flats for a next gen episode of Passive House Accelerator Live. And it is called Minimize, Maximize, or Balance, Designing for Net Zero on an Urban Site. So that's Wednesday here in North America and Thursday for you in New Zealand, very early in the morning. And then the next day, we have a special Passive House Component Spotlight with Lawrence Lidner of PH Air Seal, and he will be presenting guaranteed high performance air sealing for this special component spotlight. So that's Thursday in North America. And then the following week, we are joined by Juan Manuel Castaño Salvador of Castaño and Asociados, based in Spain. He will be presenting a project showcase of Passive House Accelerator Live, and it's called Hot Climate, Cool Solutions, Inside Seville's Passive House Hotel. There's also a link in show notes to other goings on in the Passive House community.
That sounds very cool. But,
definitely.
I think we were talking in the previous episodes about just how much work there is going on in Spain. So really cool to be putting spotlight on that. This is not only lots of really good buildings, but also that really great focus on keeping buildings cool and making passive houses work well in warm climates. So looking forward to that, or at least the replay in my case.
Right. Fair enough.
All right. Well, thank you very much, Mary, Ilka, and as always, great to chat. We'll be back again next week on the show with another interview. Thank you, and until then, have a great week. We'll be back next week on the Passive House Podcast.